Hello, and welcome to fSQCA Lesson 8. And I'm Arch Woodside. I'm a retired professor at Boston College, and it's good to see you again. I'm not sure why I say that, but because I can't see you, but do feel free to contact me anytime by email if you have some questions. Uh, and I'll give you my email address again, and you can see it in Lesson 1. Today, we're going to look at multiple outcome modeling at the case level, and something that is rarely done, but it should be done most of the time. And that's the topic. And the goal is for you to have some skill building experience at actually modeling multiple outcomes. And it's very exciting to do this, and it's the coming thing. It's going to be in the journals in the next few years. Beginning in 2024. You can find it now, but it's relatively rare. We tend to model just one outcome at a time. So let's go ahead and get started. And I'm going to put up some slides. Let me turn on PowerPoint here. All right, and the what we're going to do specifically is to look at ESG as both a combination antecedent condition as well as an outcome condition. ESG stands for environmental, social, and governance performance of firms, which is a requirement to report how well you've done related to the environment. Does your firm address climate change? Does it address pollution, for example? And there's a number of dimensions of environment reporting. And social reporting is particularly related to employees. For example, a fair wage. Do you have policies against sexual harassment and issues such as related to social? And then governance is your governance performance related to social performance, corporate social performance in general. And so ESG is a measure of corporate social performance. Sometimes they're used interchangeably in papers and articles. And here's an important point to consider: that EU, Corporate Sustainability Reporting Directive, is transforming ESG reporting. Starting in 2024, almost 50,000 companies are subject to mandatory sustainability reporting, including non-EU companies, which have subsidiaries operating within the EU or are listed on EU regulated markets. So same thing in the US. ESG reporting is mandatory. The question that is typically asked related to this is, does ESG relate to financial performance? All right. Is the relationship positive, negative, or neutral? Now, I'm going to mention that this is rather a bad question, but it's asked all the time. Almost 99% of the people frame issues related to ESG and financial performance in terms of relationships. Here's an example study that was published in 2021, uncovering the relationship by aggregating evidence from 1,000 plus studies. And This is done by these three professors and published by Stern School of Management at New York University. And what they found was a positive relationship between ESG and financial performance of 58% of the corporate studies, focusing on operational measures such as return on equity, return on assets, or stock price, with 13% showing neutral impact. 21% mixed results in the same study, positive, neutral, or negative, and 8% showing a negative results. By the way, mixed results is not for a poor study. You actually do have, if you turn to a case-based analysis, you actually do get mixed results. And this is where this study is. And what I'm suggesting to you is the two questions that are asked here are actually bad science practices. And what we really need was mentioned in lesson 2 of this program I have for you, and that is using FDRs, variable directional relationships, to report the main findings of a study is a bad science practice, because the practice provides only shallow information and not information on specific outcomes. It's doubly bad, actually, because you're not reporting much, and secondly, you're not providing much information. But secondly, it takes you away from what you should be doing. And what you should be doing is based upon complexity theory tenets, such as the tenet that reversals occur at the case level, where high X gives you high Y, but high X also gives you low Y. And the same thing with low X gives you high Y, and low X gives you low Y. And so the real issue is not relationships, but when does X affect Y in terms of high and low. And so there's actually 4 corners in any relationship that will occur if your data is if you have enough of data, such as like 30 cases or 100 cases or 1,000 cases. What comes to mind right now is thinking about Donald Trump and Black Americans. 90% of Black Americans will vote against Donald Trump, but 10% will still vote for him. So the question comes up is, the relationship is a negative one between Trump and the Black voters in the U.S., but you still have a positive relationship as well. So the question becomes, when do people vote, and why do they vote for Donald Trump, as well as why do they not vote for Donald Trump? And we want to actually get into analysis at the case level. So this is the most important statement in the whole course on fSQCA. The scientist's tools are not neutral, meaning that the method applied informs the theory constructed. So if you start talking about relationships, you're going down a bad road, that because again, it doesn't provide you much information to report, well, you got a positive relationship, and the level of explanation from a R-square, from a multiple regression point of view, is about 10% of the variance in the data. And biologists and chemists never talk about things like that. They talk about point estimates of outcomes. And we can do that in the behavioral sciences too. And a fellow named Ray Hubbard talks about corrupt research, and he's referring to relationship testing. And the book is entitled Corrupt Research. You can look it up on Amazon. I've mentioned it to you before in the previous lessons. All right. So consequently, applying multiple regression analysis and analyzing data is both a theory construction endeavor as well as an analytical tool. All right. And so and you're looking at variable directional relationships and testing using null hypothesis significance testing, NHST. Now, the American Statistical Association came out with a report in 2015 that said, don't do it. Don't do NHST. It's not worthwhile. And then the report also mentioned, why do we do it if it's not any good to do? And the main finding they had is because why we do it is because that's what we mainly teach PhD students to do. So and we teach it because we do it, and we do it because we teach it. Now, I'm not saying not to do it, but I'm saying to do it to show reviewers that you can do it and point out that it's not sufficient, and then do something really good in your analysis, such as case level modeling. So we'll go back to that point in a couple of minutes. All right. So MRA, that's multiple regression analysis, correlations, and most meta-analysis are more rubbish than substance here. And I'm not the first to say this. This is well stated in the literature. And I'm going to provide you a source that reviews this with empirical examples of what you should do. And I'll be happy to send it to you too. The what I'm going to provide you is entitled Accurate Case Outcome Modeling in Economic Psychology and Marketing. And that's a main reading for this. Now, lesson 8, we're going to have, I'll introduce you to the data, and lesson 9, we'll actually do the analysis using the data. I'll provide you with the data in lesson 8. Now, here's a quote from McCloskey. It's all nonsense, which future generations of economists, and you can put in psychologists and marketing professors as well, are going to have to do all over again. Most of what appears in the best journals are unscientific rubbish. I find this unspeakably sad. And that's a very powerful statement, don't you think? And so it's kind of shocking to find out that most of the papers in the best journals are unscientific rubbish, according to McCloskey. And again, think of Hubbard's title of his book, which is Corrupt Research, and calling for a redesign in the behavioral sciences. All right, so what we should be doing is constructing case outcome theory with empirical analysis, because it can provide an accurate prediction of specific or interval outcomes via somewhat precise outcome testing, which Woodside, Nagy, and McGehee referred to as SPOT, S-P-O-T, somewhat precise outcome testing. Now, here's a picture of Gigerenzer. He's in Berlin. He was at the Planck Institute. The German culture forces people to retire at 65. He's actually now he's 73 years old, and he's still full of vim and vigor, and he's still working brilliantly. He's one of the best scholars in psychology and in the behavior sciences in general that I'm aware of. Please don't die before you've read a couple of his papers or several of his papers. He is brilliant. And he's also highly readable, and he writes a lot of papers in English. And here's McCloskey, who said that everything it's all rubbish in the top journals. No, there's a few exceptions, but most of it is bad stuff, according to McCloskey, and she's basically correct. So we're going to look at a couple of examples of what's done typically. And this one study has close to 10,000 citations that we're going to look at related to ESG and financial performance. And here's the key result from it. And now, when you look at this is very important to actually be able to read what it says, okay? And this presents 3 models. You see the 3 models here. and you're testing whether or not the linear effect of CSP, which is corporate social performance, it relates to return on assets. You see the dependent variable return on assets, and all three models indicate statistical significance at the 0.001 level. So it's a strong relationship. And then what's called control variables, they in the first model, the first two are modeled along with CSP, and then in the second model, the debt to assets plus the total assets are modeled. So we have the numbers in this table are B coefficients, and that's a weight of influence, okay, of that particular variable on the outcome, which is return on assets. And the R square is a level referred to as a level of explanation of the variation in the data. And so the variation is a little bit less than a third of the variation is indicated by this model, okay? And the point here is that this is what the first model looks like, okay? And the B's are the betas, or the B coefficients. The betas are the standardized B coefficients. Now listen, if you don't know what the heck I'm talking about, you need to get yourself a good basic multiple regression analysis book. And the best one, I believe, is I'll provide a reference for you at the end of the course. But even though it's something that typically is not worthwhile to do, you need to do it because it's the standard practice today. If you have, for example, 100 studies, 93 of the studies will only report multiple regression results or correlation results. The hypothesis that you're looking at is that the B coefficients are not equal to 0. You see this down at the bottom of the slide? And the main hypothesis for B1 is that it's going to be a positive relationship. So people love to say that if you're concerned about social performance, you're going to actually increase financial performance. Well, down deep, that runs against Milton Friedman, Nobel-winning economist out of University of Chicago, who said we shouldn't be concerned about social performance. What we need to be concerned about is doing stuff that provides return to our stockholders. So that's the Friedman hypothesis. He's very famous for that hypothesis. All right, here's the basic hypothesis. That better financial performance results from improved CSP, everything else being equal. So if you take out the effects of your control conditions, what multiple regression analysis does is report the independent effects of each of your independent variables. And again, that really doesn't give you very much because we actually have a configuration of effects on an outcome. So we'd like to be able to actually predict when the relationship between CSP and financial performance is going to be high, and also when is it going to be low, and also when is there no influence within the cases in your data set. All right, so what the findings show is a small positive relationship between CSP and ROA in the data that was tested in this study. This is a lag study where CSP is in 1990, and return on assets is from 1991 for the 800 cases, whatever the number of cases were in the study. The number of cases are not reported in that table. And this is a table. You see the heading return on equity. So this is like return on assets, but this is return on equity. And you see the B coefficients for CSP for model 4, 5, and 6. They're positive, but they're not statistically significant. So I'm asking you to interpret these findings, but I couldn't wait for you to interpret them. I started to talk about them. But look, if you're going to get a PhD and do research publishable in journals, you need to be able to read these tables, read this type of information. And here's the model 4 test CSP along with debt to total assets. And you would expect a negative relationship. The larger the debt, the lower the financial performance. And it's found negative in model 4, negative in 5, negative in 6. And of course, you got the same data set, so you would expect that. And if you look at for total sales, it's not significant in model 4, and it's not tested in model 5 and 6. And the R square is what comes to my mind is it's pitiful. It's rather small. R square goes from 0.0 up to 1.0, and the F is highly significant, the 0.05 level. And just remember again that the American Statistical Association tells us not to do this type of reporting. So I ask you to interpret these findings. I will wait while you do so. We've just done it because we only have a few minutes together. The interpretation is CSP 1990 not found to have a statistically significant positive impact on ROE for 1991 in any of the 3 models. And such research is doubly bad because you are no longer studying firm cases, and the analysis fails to examine and interpret the inherent complexity of the data. But it's important, necessary to do this reporting because that's what everybody does. And if you want to get your work published and accepted, you want to show this. But hopefully you're going to include something good. Now, this is how often we see in articles, we see this type of figure of where the BI represents the B coefficients or the betas if you standardize your data. And so here's corporate social performance effects on, and what the arrows indicate is singular influences on the outcome. All right. So you propose that this is going to be positive. P1 is going to be a positive effect. P2 is positive relationship. B1 a positive relationship. Okay. The core question in the research asks and proposes what is the individual impact of the BIs on each independent variable, on the dependent variable? Are the adjusted R squares substantially high? Like high R square would be like 0.4, 0.7 would be high levels of explaining the variance. And McCloskey and McCloskey's colleague Ziliak tell us that looking at standard errors of variation in data is just bad practice. This is what we want to do. We want a visual example of complex antecedent conditions where we have both corporate social performance 1990. If we had the data available for the Waddock and her colleague, Sam Graves, and as well as the negation of corporate social performance. You'd like to study each of those as inputs, antecedent conditions. Same thing with debt, total sales, total assets, I got total assets twice here. If I go back here to the previous slide, let me go back to the previous slide. This number of employees, that should be number of employees. I listed that wrong. Number of employees, because I got that done twice. And so I'll correct that. I won't hold us up. Now look at the outcome here. The outcome here, we're talking about uh, 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 combining ROA with ROE. And I'm suggesting to you is there's such a thing as both of them being negative, both or in some firms, both of them being positive. And one is positive, one is negative, and then the first is negative and the second is positive. And this is what I've referred to and with my colleagues as four corner analysis of outcome. If you've got two particular outcomes you're looking at. So the core question the researcher asked and constructs theory, which of the 32 configurations of cases do the data set include? A few cells in the 2 by 2 by 2 by 2, 1, 2, 3, 4. I got one extra one here. Let me go ahead and get rid of that right now. Okay. Get rid of that right now. All right. So, no, we do have 5. I'm sorry. We ought to keep it in. All right. If you got 2 by 2 by 2 by 2 by 2 here, in terms of positive or negative antecedent for each of these conditions, that would be 32 different possible combinations. All right, you could have high CSP and all the other 4 being low, or that all 5 could be high. There's actually 32 different combinations here, and the possibilities are basically they could be having positive impact or negative impact or no impact. That they're irrelevant. That particular condition would be irrelevant for predicting the outcome, where you have 4 different outcomes. All right. And we can come up with high scores in each of these 4. Like this would be high, high, and high positive, and say top quintile in both. That means that we're in the top quintile in both. And here we'd have, say, in the tilde that is sideways tilde indicates negation, where they're both negative. I think you get the idea here. And so, and again, I made a mistake on typing this up. It should be total number of employees. So you have big employees by number of employees and small. And so look, we can add in background information, and this is a basic template for case level modeling, where also we have 4 outcomes here instead of 1 outcome. We can look at the combinations of the outcomes between that would include, say, for 1915, E, S, and G. And I happen to have data here with my colleague who works now in Australia. His name is Lars Isaacson, and I'm going to show you that data. We have data for this, where we have ES and G for Swedish companies in 2011, along with return on assets for 2011. So remember, we got 32 different combinations here for the input, and for the output, we got 32 different combinations, okay? And then we can throw into analyzing, say we have a situation where ESG is positive and return on assets is positive, indicating all 4 are positive. And do we have actual companies in the data set that exhibit that type of impact? And then we'd like to know what would those companies be in terms of, are they service-oriented or product-oriented companies? Do they produce a service or a product or both? And then firm size, are they large or small, defined, for example, by total assets? And are they global or domestic? And then are they B2B firms or B2C firms? And if you look at this, and let's just say we divide the data up into 3 or 5 levels of firm size. Let's say 3 levels of firm size, global and domestic, and 2 service versus product, or both. So that's 3 levels of that. So, and then B2B and B2C, or both. So that's 3 times 3 times 3 times 2. So that would be 27 times 2, or that would be what, 54 combinations of representing different firms in the data set. Now, of the possible combinations, some of them will have 0 companies in those combinations. And so that's going to pretty much finish up lesson 8. The basic conclusion of lesson 8, to think in terms of combinations, okay? Lesson 9 would show a few firms are able to achieve high membership scores in the following complex outcomes. So this is an outcome, okay? Outcome possibilities. And again, if you really think of 3 levels of each, where you got high, medium, low environmental performance, high, medium, low social performance, high, medium, low governance performance, and high, medium, low ROA performance, return on assets. So if you did that, you'd have 81 combinations of performance. And one question is, would you have any firms that perform high on ESG as well as return on assets? I mean, that would be really interesting to see in your data set. So we're going to look at 66 firms in lesson 9 and actually do calculations. I mean, it's very, very exciting to look at this. And and before we stop, I just want to mention that I'll go through these in lesson 9, but here's the data set. Here's 20 companies. These are all Swedish companies. Will be our data set for analysis. And this is the E-performance in 2011 for these 20 companies. And ABB, that's an actual company. And AAK is not doing so well in terms of environmental evaluation. And these are calibrated data. And ABB is doing very well. I used to own stock in ABB. It's a fine company. And anyway, look, this is another 20 companies, and this is the rest of the companies. We have a total of 60. What is it? 60. It says I think it's 66 companies in the data set. 67 because the first line is taken up by what the condition is. So we're not going to cover that right now. We're going to stop with lesson 8, and I think you can see the exciting possibilities here of switching away from and actually replacing variable directional relationship research with point estimate of outcomes. And this is what Hubbard has been so excited about, as well as McCloskey really criticizes VDR research, but doesn't actually provide us with a solution. Hubbard does, Hubbard in corrupt research, but he doesn't actually do it. And so you have to do it and show people and rub their noses in it to get them to make this change. So listen, it's been great seeing you today. We'll actually do the data analysis in lesson 9. So take care, and I look forward to seeing you in lesson 9. Goodbye now.